All right, so for this worksheet, what we're going to do is to practice each one of the three elements that will be on the exam. Again, if you can do this exercise well, you should do very well in the exam. These are going to look very familiar when you get to the exam day. So the first one asks you simply to take a regression equation that's already been calculated and to use it. So here we have a regression equation, y equals 2.96 plus 0.02x. Okay, so what you'll need to remember in order to fill this one out is one, what is the independent variable? In other words, our study, which one is that? Is that the y variable or the x variable? Next, which one is the dependent variable? GPA. Again, is that the y or the x variable? Because then using those, what you're going to do is you will plug in one of these variables. So here, studying 8 hours per week, you'll plug that in order to try to get a predicted grade at the very end. So remember, this regression equation is basically like an algebraic equation for a line, but it's one in which if you know one of the variables, you can find the other one. So what I've given you is two different possible values for one of the variables, the independent variable, study time, and I've asked you in both situations to figure out what your grade would be as the outcome. Next, the second one is I've given you a value for the second variable, which is GPA, also the same as grade. If your GPA or your grade is 4.0, I want you to work backwards from there to figure out how many hours you would have to study. Okay? So try to remember what you can. If you don't remember it right away, don't worry. Just go back and take a look at some of the videos, some of the lecture videos, and what we've done on some of the previous worksheets. So that's the first page. On the second page here, what you're going to do is to complete a chi-square. Now notice on here, I have not given you any table of chi-square values. So a part of completing this worksheet is trying to figure out how you take the information in this paragraph and put it into this chi-square table. You'll notice what I have done is to give you a 2 by 3 chi-square table. From that, you should assume that the data will fit into a 2 by 3 chi-square analysis. Okay, so what you want to take a look is in reading through this in the next 3 years, only 3 of the 22 people in the stress management group. Sorry, let's actually go back. You read a newspaper article that describes a study of whether stress management can help to reduce heart attacks. The 96 subjects, there's one piece of data, all had reduced blood flow to the heart, and so they were at risk of a heart attack. They were assigned at random to 3 different groups. Okay, notice 1, 2, 3. The article goes on to say one group took a 4-month stress management program, another underwent a 4-month exercise program, and the third received the usual heart care from their personal physicians. Over the next 3 years, only 3 of the 22 people in the stress management group suffered cardiac events, defined as fatal or non-fatal heart attack, or a surgical procedure such as a bypass or angioplasty. In the same period, 7 of the 34 people in the exercise group and 12 out of 40 patients in the usual care suffered such events. So, notice, I've given you 3 categories for one side, but only 1 category for the other side. You got to figure out what the other category would be, and then how to fit this information, like this 22, 34, 7, 3, 12, 40. How do you fit that information into these squares? Now, if you've forgotten how to do this, you can take a look down and remember the basic elements of the chi-square include observed, expected, deviation scores, and then O minus E squared divided by E. And in the end, you're going to sum all those up to get the chi-square value. Okay, so take a good first shot at that. We'll bring it into class and answer any questions you have on the day that we do review day. Next, This is the another regression worksheet, but in this case, you're actually going to have to calculate the regression equation. So you're trying to find a new job, but you just can't seem to squeeze in the time to apply to many locations. In fact, you're seriously considering just dropping a single resume off at a campus bookstore. What difference could it make anyway, you think? I'm just a college student. No one will want to hire me. However, before you let your irrational self take over, you think, what would Dr. Oakes-Mueller do in my situation? Well, he'd probably spend 16 hours making an animated chart of something that I'm going to forget before I even walk out the door. But then you think, what would he do if he weren't so oddly obsessive about his PowerPoints? Then it hits you. He'd use statistics. So, thinking quickly, you ask your 5 closest friends what their hourly wage is at work. Then you ask them how many applications they submitted before getting hired. You plot them in the chart below. Using these data, develop a regression equation that predicts your hourly wage based on the number of applications you submit to various employers. Okay, so I've given you applications, which is X, or the predictor variable. You're trying to get hourly wage, or Y, the criterion variable. So what you want to do first of all is transplant these down here, right? These are your X and Y variables. But then what you have to do is try to remember how to calculate each one of these. Well, you don't even have to remember it. So if I want to know, how do I calculate out, for instance, the X deviation? Well, I simply go down here and reference deviation scores. X deviation is the X minus the mean score of X. Okay, so I come back up here. So turns out it's going to help me a lot if the very first thing I calculate is going to be the mean score of X and then the mean score of Y. Using those, I can then calculate deviation scores for each of these variables. What's the cross product? Well, again, if you want to know, if you've forgotten, just go down, take a look in reference, and you find the cross product is that deviation score of X times the deviation score of Y, and so on and so forth. So I've given you columns for each one of these. So the X deviation squared, Y deviation squared, and then ultimately areas to put each one of the relevant variables that you'll be calculating. Again, each one of these you can find on that page below in terms of instructions on how to calculate it. So you'll do that, and then what you want to be able to do is to at least write one sentence indicating how applications predicts hourly wage. The final page on this review sheet has to do with ANOVAs. So in this situation, you want to think about this. Here's a case study. Patients suffering from severe headaches were divided into 3 different treatment groups, in which one group of patients received treatment A, another treatment B, another treatment C. After 1 year, let's see, why do I only have, and another one that should say, and another one, treatment D as well. After 1 year of treatment, the number of severe headaches in a 1 month period was measured. So this person had 7, this person had 10, this person had 10. The people in group B, this person had 3, the second person had 3, third person had 3. So first of all, you want to decide which ANOVA design is needed for this description. Well, in our case, you've only studied between groups ANOVA, so you know it's between groups. We'll talk about some other ones later. Next, what you want to do is you want to calculate out the sums of squares, okay? So what I've done is I've given you an ANOVA summary table before, but what you'll notice is this table looks a lot more blank than your earlier ones. So if you want, you can pull out your old worksheets and figure out, what do we write in here? What goes in this first column? In other words, what should we title this? What goes in the second column and what goes in the third column? Now, notice I've given you the sum of squares total value right there. So all you need to calculate out is the other 2 sum of squares. So let's call this first one sum of squares between, and the second one sum of squares within. But what you need to figure out is, how do I get to my sum of squares? In other words, What's this third column have to be? How do I work backwards from that? And what should my second column be as well? Okay, so you'll do that once you've finished it. What you want to be able to do is to find the appropriate critical value. You have to use the degrees of freedom. And what's your decision? Is it significant or not? And if it is, what does your decision mean practically? And even if it's not, what does that mean practically? So fill out this worksheet, bring it to class, and we'll talk about any questions or issues that you have on each one of the components.